Okay, so we have our modified data column, and again, we chose to calculate these based on what the reading tells us to do for an inverse relationship. What we want to plot are the y values unmodified. Okay, so we want to plot, we want to plot the y values just as they were versus 1 over the weight. So we're going to make an entirely new chart. All right. Now I want to highlight the data that I'm interested in. I want highway mileage and the inverse values. And I'm going to go through the same steps to create a chart. I'm going to go Insert, XY Scatter, and pick the first one. And I should see a new chart that looks like this. Alright, so we have our modified graph. It looks linear, which is good. That indicates that we did pick the right relationship type in this case. I was just saying to the class when it was paused that if it doesn't look linear, then you should try one of the other modifications and see if you can find one that does linearize the data. Now there is a problem with this chart. If you look at the values and how they're plotted, the x-axis is looking like the mileage values, not the inverse weight values. The inverse weight values have been plotted on the y-axis. We need to get that switched. So the way that we do that, if we right-click on the chart, we go to Select Data. And I'm going to make sure my chart's not in the way of my data, so I'm going to drag it down actually. Do that same thing. Select Data. And I need to edit my data series so that the x values are where I want them to be and where the y values are where I want them to be. So I click Edit. It brings up another screen. And Series X values, I want to select those. Okay? The way you select them is this little button here. And notice what it's doing. It's highlighting the current x values. I don't want them to be highway mileage. I want them to be weight. So I just click and drag and then click this button, and it's going to fix that so that the inverse weight values are on the x-axis. Same thing for the y values. I'm going to click on this button. Right now it's selecting 1 over weight. I want that to be mileage. And I click again. And I click OK. And OK again. Now, when I go back to my chart, it's correct. I've got mileage here. I've got inverse weight here. So when we look at this graph, it looks like it's set up the way that we want. We've got unmodified y values versus inverse x values. The next thing we want to do is just clean up and label the graph with the plus button here. We want axes titles. I'm going to pause it and go ahead and do that. Alright, so we have cleaned up the graph. We've labeled it properly, although I misspelled highway. And the next step would be to find the equation that describes this data. Okay? We've linearized it, so I want to put a trend line on the data. I can do that here with the plus key as well, if I go down to trend line. Notice it puts on a line of best fit. This trend line is pretty close to hitting all those data points. We're going to use that trend line to come up with our equation. I want to click this little menu button here and go to More Options. Now, we've linearized the data, so we want to make sure that linear is selected here. But if I scroll all the way down, the thing I'm really interested in is the equation here. Notice an equation pops up. That's what I wanted. Okay, so let me close that. Make the font a little bit bigger for you. All right, now this is where it's important stuff coming, okay? This is the equation that fits this linearized graph. It's also the equation that describes that initial curve, okay, the curve that we had here in the data to start with. The linearized graph is just a tool to get the equation for a curve. But we can interpret what we've gotten here as important to describing the relationship. Now the first thing you're going to want to do is change the y and the x to what we're actually plotting on the y and x axis. What I mean by that, on the y axis here we have highway mileage, right? So instead of writing y, I'm just going to write out the y-axis variable, which is highway mileage. The x variable. Well, on the x-axis of this linearized graph, I've got 1 over weight. Okay. That takes care of the y and the x. I put it in terms of what I'm actually graphing here. My next step would be to deal with this number and this number. Think of your standard linear equation, y equals mx plus b. This would be the m term, the slope. This would be the b term, your y-intercept. Now in this case, if I just eyeball the graph and think about projecting this line backwards, you can see that it's pretty much going to hit at the origin. And this number is telling me exactly where does it hit at the origin. Okay? It's giving me a value of -2. Okay? So, you know, it would hit somewhere in here. One thing that you can do whenever you do this analysis is think about, is that value really telling me something, or is it just a little bit of statistical error and I can really assume it's 0? The rule of thumb is if your intercept is less than 5% of your biggest value on the y-axis, you can drop it. Okay? In this case, the value is about -2. My largest data point had a mileage of 48. So 2 out of 48, that's less than 5%. I'm going to suggest when that's the case, we just delete the intercept and treat it as a 0 intercept, a graph that starts at 0 at the origin and increases from there. Okay? So we're left with one thing we need to clean up. That would be the slope value here, or we'll call it the coefficient. The coefficient that is multiplied by 1 over weight. We would want to round it to a reasonable number of significant figures. This has 6 significant figures. If we go back to our data that we initially entered, none of our data points had that much. Our weights had 4 sig figs, our mileage had 2. So I'm going to suggest we round this down a little bit. There's no specific rule of thumb on that, but I'm just going to split the difference. I'm going to round 103,327 to good old 103,000, because I don't think I'm accurate up to 6 decimal places. In other words, my uncertainty lies kind of in the 3. And then one last thing to finish this off, we need units on any number. Okay, this is a numerical quantity. We don't need units on weight or highway mileage. That's kind of embedded in the variable. But this coefficient needs units. And we kind of interpret it as we would interpret a slope in this graph that we've created. The simplest definition of slope is rise over run. So we think about what would the units be for highway mileage, for the rise units over the run units. And this is where it gets kind of sticky. The units I would want to attach then would be miles per gallon per, because that's rise. Run, I'm going to put another parenthesis. This is going to get kind of ugly before it cleans up. So it's miles per gallon divided by 1 over pounds. That's not pretty. Let me try to get this all on one line. So I'm going to pause for a moment and discuss how we could make